Look up. Just a handful of stars in a sky that holds hundreds of billions, each a sun, many with their own worlds, trillions of planets, screaming with potential. Statistically, the cosmos should be teeming, a vibrant cacophony of alien voices, flashing lights, and impossible wonders. And yet, for decades, we've aimed our most sensitive instruments at the infinite dark, listening, watching, straining to catch a whisper. All we've ever found is an abyss of echoing, profound silence. It's the greatest cosmic mystery, a paradox that challenges everything we thought we knew about life itself. Why, in this boundless ocean of possibility, have we found nothing? The silence, that gaping void we just talked about, it didn't just sit there. It screamed for an answer, and our first, most audacious response was to listen, to point colossal ears made of metal and silicon at the heavens, hoping to catch a stray whisper, a deliberate call. This was the birth of SETI, the search for extraterrestrial intelligence. Our gambit was simple, brilliant, and utterly desperate. If they're out there, and they're anything like us, they'll be broadcasting radio waves. They're the cosmic bat signal. They travel unimpeded across the vastness, cutting through dust and gas, carrying information at the speed of light. It's the ultimate long-distance communication. But here's the cosmic gut punch. Imagine trying to find a single specific radio station on Earth by randomly tuning your dial for 1 second, once a year. Now multiply that by 1 million galaxies, each with hundreds of billions of stars, each potentially swarming with planets. We don't know where they are, when they're broadcasting, or even what frequency they'd use. It's not just a needle in a haystack. It's a specific molecule of hay in a universe made of haystacks, each moving at unimaginable speeds. For decades, brilliant minds have dedicated their lives to this, scouring billions of frequency channels, devouring petabytes of data, straining to hear anything beyond the universe's own static. And yet, the receivers remain terrifyingly, stubbornly mute. The cosmic phone isn't just ringing. It's not even connected. The cosmic phone line, it seemed, was dead. Or perhaps we were just calling the wrong number. What if advanced civilizations weren't broadcasting their existence into the void like some interstellar radio show? What if they were too busy, too ancient, or simply too different to care about our puny radio waves? This chilling thought ignited a new, even more audacious hunt, the search for techno-signatures. Forget the faint whispers of radio signals. We're talking about the footprints of giants, the cosmic litter, the architectural marvels that only a truly advanced civilization could forge. Imagine a species so ancient, so utterly dominant, that it outgrows its home planet, its solar system, even its entire star. Where does it go for energy? The ultimate power source, its sun. This is where the concept of the Dyson sphere explodes into existence, not a solid shell, but a vast, unimaginable swarm of solar collectors orbiting a star, soaking up every last photon of its energy. Think of it as wrapping your entire sun in a colossal blanket of pure power collection. A civilization building such a structure wouldn't just be using energy, it would be devouring it on a scale that beggars belief. And that act of consumption, that gargantuan feat of engineering, would leave an unmistakable trace. The star wouldn't just dim, it would scream in infrared radiation, numbered. All that captured energy has to go somewhere, and it radiates as heat. So we're scanning the heavens, not just for radio static, but for stars that are unnaturally cool in visible light, yet blaze with an impossible, artificial warmth in infrared, like a cosmic furnace, betraying its hidden purpose. But Dyson spheres are just the most famous example. The hunt for techno-signatures extends to every possible sign of intelligent alteration of the cosmos. Could an alien civilization have polluted its atmosphere so profoundly that we could detect its industrial exhaust from light years away? Could they have constructed gargantuan structures visible as anomalous light curves? Perhaps they've terraformed entire worlds, or even reshaped star systems, leaving geometric patterns that defy natural explanation. We're talking about the cosmic equivalent of finding an entire city built on the moon, or a massive dam redirecting a planet's oceans. These aren't just theoretical musings, they're the very targets of our most powerful telescopes, like the James Webb Space Telescope, meticulously sifting through the light from distant suns for any hint of intelligent design. The implications are staggering. If we do find one, it shatters our solitude forever. If we don't, well, that silence gets even louder, even more profound. This pursuit, this obsessive quest to find out if we're truly alone, demands every ounce of our ingenuity. And if you're as obsessed with these cosmic secrets as I am, if you want to keep exploring the universe's most profound questions with me, then do me a favor, incinerate that like button and subscribe to the channel. Let's decode the cosmos together. All right, so the radio silence was deafening. The techno signatures? Still elusive, like ghosts in the cosmic machine. But what if we're looking for the wrong kind of evidence? What if the universe isn't filled with colossal alien structures, but rather with something far more subtle, yet infinitely more profound? What if it's teeming with life, just not the kind that builds megastructures or broadcasts their reality TV shows across the void? This is where the game changes. This is where we stop looking for the grand impossible and start sniffing out the very breath of life itself. We're talking about biosignatures. These aren't alien cities. They're the chemical fingerprints left behind by biological processes. Imagine a planet light years away. If it has life, that life is interacting with its environment, inhaling, exhaling, metabolizing. And those interactions release gases into its atmosphere, gases that, in isolation, wouldn't normally be there in such quantities or in such a specific, unstable combination. Think about it. Earth's atmosphere screams life to anyone with the right tools. We've got a massive amount of oxygen, a highly reactive gas that shouldn't persist unless something is constantly pumping it out. That something is plants, algae, photosynthetic bacteria, all furiously generating it. We've got methane, another gas that breaks down quickly, yet is continuously replenished by biological activity. These aren't just random gases. They are the exhalations of a living world, a planetary lung breathing in the cosmic dark. And now, for the first time in human history, we have the eyes to see it. The James Webb Space Telescope isn't just a pretty picture machine, it's a cosmic chemist. When light from a distant star passes through the atmosphere of an exoplanet orbiting it, certain wavelengths of that light get absorbed by the gases present. It's like a cosmic barcode scanner. Each gas leaves a unique, unmistakable dark line in the starlight's spectrum, a precise chemical signature. Webb, with its unparalleled infrared vision, can read those barcodes with astonishing clarity. It's sifting through the light of thousands of distant worlds, meticulously searching for the telltale signs, the sharp absorption lines of water vapor, the deep cuts of methane, the undeniable presence of carbon dioxide, and yes, the ultimate smoking gun, oxygen. This isn't about finding little green men. This is about answering the most fundamental question: is life, even microbial, a common occurrence in the cosmos? If Webb detects a planet with an atmosphere choked with oxygen and methane, gases that would quickly cancel each other out unless replenished by an active biological engine, then it's not just a hint. It's a profound, undeniable declaration. It means that world is alive. It means our universe isn't just a sterile void. It's a vibrant, breathing tapestry. The thrill, the sheer mind-shattering possibility that we are on the cusp of detecting the actual breath of an alien world is almost too much to bear. It transforms the great silence from a mystery of intelligence to a question of ubiquity. Are we alone in our sentience, or alone in our very existence? The answer may be just a spectral line away. So, we've gone from straining to hear the faintest radio whisper to microscopically analyzing the very breath of alien worlds. We've cast our nets wide, deployed our most sophisticated instruments, and poured billions into this cosmic hunt. And yet, the silence persists. It's not just a lack of evidence, it's a gaping, terrifying void that screams a different question. What if the problem isn't our search methods, but something far more fundamental? What if the universe is teeming with life, but it never reaches a stage we can detect? This brings us to the most unsettling idea in all of astrobiology, the Great Filter. Imagine a cosmic bouncer an unseen hand, a hurdle so monumental, so utterly devastating, that very few, if any, ever pass through it. It's a bottleneck in the evolutionary path, from the very first spark of life to a grand interstellar civilization. And the most chilling part, we don't know if it's behind us or, terrifyingly, still ahead. Consider the possibilities. Could the filter be at the very genesis of life itself? The leap from inert chemistry to self-replicating organisms might be so astronomically improbable that it's a 1 in a trillion event. Maybe simple life does pop up everywhere, but only a cosmic lottery winner like Earth ever got the initial spark. Or perhaps the filter lies in the transition to complexity. Remember the style example, that singular, almost miraculous fusion of simple cells that gave rise to all complex life on Earth, the eukaryotic cell? What if that was the barrier, a genetic Gordian knot that most planets never untangle, leaving them forever stuck as a thin film of microbial slime, breathing silent atmospheres, never building, never speaking? But the most terrifying possibility, the one that keeps astronomers awake at night, is that the great filter lies ahead of us. A cosmic cliff edge that nearly every advanced civilization inevitably falls over. Think about it: nuclear war, climate catastrophe, rogue AI, or perhaps some unknown existential threat we can't even conceive of yet. If every civilization, upon reaching a certain technological threshold, inevitably self-destructs or succumbs to an unavoidable cosmic peril, then the silence isn't a mystery, it's a warning. We're not alone because everyone else has already passed through the final fatal gate. And then there's the humbling reality of our own limitations. The cosmos is unimaginably vast. Our search, for all its ingenuity, is still just a pinprick in an infinite ocean. We're like ants on a single beach, trying to detect human civilization by listening for specific radio frequencies. What if advanced civilizations communicate in ways we can't even fathom, through quantum entanglement or manipulating space-time, or sending messages encoded in the very fabric of reality itself? What if they're not interested in broadcasting, but in retreating into hidden, energy-efficient pocket universes or black hole-powered sanctuaries? Our silence might not be a lack of others, but a profound testament to our own cosmic immaturity, our inability to perceive the grand symphony playing out just beyond our crude instruments. The very act of searching, of grappling with this profound silence, forces us to confront our place in the universe and the terrifying, beautiful possibilities of what awaits us, or what might never be. The great silence, it hangs over us, a cosmic weight, a question that echoes through the vast, cold reaches of space. Are we the exception, the lucky anomaly, having slipped through the great filter by sheer, improbable chance? Or are we simply not listening hard enough, not looking in the right places, still infants in a universe that speaks in languages we haven't even conceived? This obsessive quest to find out if we're alone isn't just about scientific discovery. It's about defining what it means to be ours. It's about our inherent yearning for connection, for understanding, for a mirror in the cosmic dark. Every radio dish pointed at the stars, every telescope dissecting the breath of a distant world, every theory about the filters and the silence, it's all a testament to humanity's unyielding curiosity, our refusal to accept that we are the only conscious flicker in an otherwise dead universe. The search continues, relentless, fueled by hope and an ever-present, chilling doubt. And until that moment of contact, or the definitive proof of perpetual solitude, we remain the universe's lone, questioning voice, screaming into the void. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.